So a lot of my work is looking at roots and root hairs under a microscope. Roots and root hairs are the tissue that uptake water and nutrients, so understanding how they work gives us a better understanding of how plants work. They're so much less studied than the top side tissues of the plant, so my goal is really to figure out a little bit more about that to see if we can help contribute to how well plants can grow. The imaging that we're going to be doing is Propidium iodide staining. The question that I'm trying to answer with this imaging is the cell length different between wild type and my mutants? And that's one way that I can say this gene is required for root growth. We soak them in Propidium iodide. We image them with the confocal microscope, which basically has a laser that can excite the Propidium iodide to glow, and that's what we are actually going to be looking at. Most people know plants need nutrients, but what those nutrients are and how they get into the plant, that's happening on the cellular level. And so when I'm looking at how things are moving around the cell, that can include things like nutrients, but it also includes the receptors. So a lot of it has to be taken into the cell using a very specific protein. For me, I feel like this is really about finding a way to produce more stable crops. And what that really means is crops that can grow in different environments, crops that produce better, even under stress, being able to have a more consistent product that people can have access to. So finding a way that maybe we can reduce the amount of shipping that we have to do if plants can grow where they're actually destined to be. Funding basic research is an important part of how we get to a more food secure world.